Hello everyone. So what I've got going on here today is I need to do the load calculations for the new sub panel that's already in service and the new main panel that I'm going to install, that I'm planning to install anyway. And I already know that this 100 amp main breaker and this panel and the cable I installed are adequate to serve this this panel, because we're running the house off it on being fed from over here. This is the Guardian Generac transfer switch panel, which is actually a 100 amp sub panel itself. So I have a 100 amp breaker from here feeding into here. But the interesting thing is that this panel is fed from the main panel from a 70 amp breaker. So ultimately this only has 70 amps available to it. All the loads that are in here were always in here, and this was always just fed by 70 amps. So I know that it's not going to be a problem at all. It never has been. But even with that being said, I can't just tell the electrical inspector, oh, it's good enough, because it's always been good enough. I have to be able to show that I did the code compliant feeder or service calculation. In this case, it's a feeder load calculation. So that's what this is all about. I actually created a spreadsheet for the main service load calculation and the optional service load calculation method for the sub panel. So I'm going to go through what I did with these. And this is all according to 220.82 and 220.82b in the NEC. This is based on the 2020 NEC. Actually, I referenced 2020 here, but it's the 2023 code that I used online. And by the way, while you're working with this, if you're ever doing it, Annex D in the code book has examples of how to do this. Of, you know, they walk through examples with made up numbers, you know, example numbers, and show you how to do the calculation. So if you have difficulty understanding the written word of the code, which anybody has difficulty with that if they're not very familiar with it, you can also use the examples to help you decipher what they're talking about. So a major goal of doing this service load calculation exercise is that when you're installing solar and you're backfeeding it onto the load side of the main breaker, you need to know that that power that you're backfeeding through a circuit breaker into the bus bar, plus the power coming in from the service, can't overload the bus bar. So theoretically, it's possible that you can have big enough loads on this bus bar that the current coming in here, we'll say this is a 200 amp bus bar. If you have a 200 amp breaker here and you have 62.5 amps coming in here, and you try to pull 250 amps on this 200 amp bus bar, you do have enough power supplied in to do that. You're overloading the bus bar, and that's a code violation. So that's the point of why I'm doing this in the first place. If you are overloading the bus bar, you can decrease or derate the main breaker. So I'm actually planning to install this 150 amp main breaker, even though this bus bar is a 225 amp rated bus bars. Because if you add the 150 plus the 62, it comes in way below. And that leaves me more room to add potentially more solar in the future. Like if I put a solar system out in the barn, I can feed it into here also. Regardless if I add more solar or not, I need to know that I can install that 150 amp main breaker in here. And in order for this to pass inspection, the inspector is going to want to know if that 150 amp main is adequate and code compliant for this house. So if I do this load calculation, I'll be able to show the inspector that 150 amps is in fact more than adequate for this house, even without the solar input. It's actually, the load I calculated on this is 85 amps. Theoretically, I could put a 100 amp panel in this house and it would be okay. But I'm going to have 150, so that should satisfy the inspector. Theoretically, anytime you're installing a new sub panel, like I installed one in my garage, I made a video about that, you should do this calculation. It's the optional calculation method for service and feeders. And so this is a feeder coming in here. So by doing that calculation, you'll know that the correct feeder size for the load you're trying to serve with your new panel if you put in a new sub panel. So this applies to sub panels just as well as services for single family dwellings only. Okay, so let's go ahead and we're going to get into some code and show you some number crunching and show you how this is done.
We'll be walking through the National Electrical Code 2023 version, Article 220.82. Optional feeder and service load calculations for a dwelling unit. Notice this section applies to a single dwelling unit. So this is a one-family home or a one-family apartment unit. I created an Excel spreadsheet to organize the calculations and show you how each step relates to a corresponding code reference. If you'd like to receive a copy of my Excel spreadsheet, you can send an email request to heymanabouthome@gmail.com. Please don't try to abuse this offer. I'm not offering any personal consulting services, but questions in the comment section might be helpful for someone watching this video. Let's look at 220.82, Dwelling Unit. 220.82a, Feeder and Service Load. This section applies to a dwelling unit having the total load served by a single 120 240 volt or 208Y 120 volt set of 3-wire service or feeder conductors with an ampacity of 100 or greater. A side note, the minimum service requirement for a dwelling is 100 amps. There are no modern services that are under 100 amps. It shall be permissible to calculate the feeder and service loads in accordance with this section instead of the method specified in Part 3 of this article, meaning you can use this optional calculation instead of the standard calculation. Here's the meat and potatoes of this section. The calculated load shall be the result of adding the loads from 220.82b and c. Feeder and service entrance conductors whose calculated load is determined by this optional calculation shall be permitted to have the neutral load determined by 220.61. We'll be working with 220.82b and c first. I'm not concerned with calculating the neutral load because that's really only needed if you're running an undersized neutral. We shouldn't normally be doing that. Neutrals shouldn't be undersized like they used to, given the increased harmonic distortions on them by modern electronic equipment. The SCR cable used to feed the subpanels in this house have a neutral that's the same size as the phase conductors. B. General loads. The general calculated load shall not be less than 100% of the first 10 kVA plus 40% of the remainder of the following loads. So we include the first 10,000 volt amps plus 40% of the volt amps over and above 10,000. For example, if we had 15,000 volt amps, we'd add 10,000 plus 5,000 times 40% to calculate the general load demand. .82b defines 4 types of loads we must include. 1. 3 volt amperes per square foot for general lighting and general use receptacles. The floor area for each floor shall be calculated from the outside dimensions of the dwelling unit. We have to use the outside measurements of the building, not the inside floor space. And if we have more than one floor level, we need to include every level. Next sentence. The calculated floor area shall not include open porches, garages, or unused or unfinished spaces not adaptable for future use. So we're not including a garage or a cellar or attic that can't be finished into living space. I'll demonstrate later how including all the unused spaces in your house adds only a little difference to the load calculation. It's no big deal for me at all if I were to double my living space. 2. 1500 volt amperes for each 2-wire 20 ampere small appliance branch circuit and each laundry branch circuit covered in 210.11C1 and C2. You can make it your homework to read 210.11C1 and C2. They refer to the branch circuit requirements for kitchens, dining rooms, and a washing machine circuit. Minimum code requires two 20-amp receptacle circuits in a kitchen. They're mostly around the countertops, but these circuits can also provide receptacles in a dining room. And a 20-amp receptacle circuit is required for a washing machine. Each of these three required circuits are added at 1500 volt amps for calculating general loads. 3. The nameplate rating of the following, A through D. A. All appliances that are fastened in place, permanently connected, or located to be on a specific circuit. For example, a dishwasher is fastened in place, but a toaster isn't. If you have a specific circuit for a microwave, you'd include that. I think you should anyway. My refrigerator is located such that it can only be on a specific circuit. So is my sump pump and my furnace. We don't include garages in this calculation, so I'm not including garage door openers. They're so low energy and intermittent in use they hardly add any demand anyway. Can you think of other appliances that are fixed in place? How about a garbage disposal? We don't have one of those since we're on a septic system. B. Ranges, wall-mounted ovens, counter-mounted cooking units. These must all be added according to their nameplate rating. That's as straightforward as it can get. C. Clothes dryers that are not connected to the laundry branch circuit specified in 220.82 B2. These will be 240-volt electric clothes dryers that aren't plugged into the laundry branch circuit. D. Water heaters. These might be an electric water heater or a gas water heater that plugs into electric power. 4. The nameplate ampere rating or kVA rating of all permanently connected motors not included in 220.82 B3. A well pump would fit this category, but I don't have one. C. Heating and air conditioning load. The largest of the following 6 selections, load in kVA, shall be included. 1. 100% of the nameplate rating of the air conditioning and heating. I'll be using the air conditioning load in my house. That's actually the largest single load I have. 2. 100% of the nameplate rating of the heat pump when the heat pump is used without any supplemental electric heating. I don't have a heat pump, but there's a possibility I might add a mini split in the attic, so I might need to consider that as a fixed appliance load. 3 through 6 don't apply to my situation, but they're easy to understand and I'm suggesting you take them on as homework. If we recall 220.82a, the calculated load shall be the result of adding the loads from 220.82b and c. And section B tells us we need to calculate the general loads based on adding 40% of the loads greater than 10,000 volt amps plus 10,000 volt amps. So we add that to C, the heating and air conditioning loads, to get our final result. Let's do a quick and dirty example, then we'll dive into the spreadsheet to cover things in detail. The total of our general loads is 15,000 volt amps. If the total is 10,000 or less, take that number and skip the rest of this calculation. Subtract the first 10,000 VA, multiply the remainder by 40% or 0.4. Add the result to the original 10,000 VA. General loads equals 12,000 VA. For this example, let's say the air conditioning load is 5,760 volt amps. Add them up. 12,000 plus 5,760 equals 17,760 volt amps. Now for the fun part. 17,760 volt amps divided by 240 volts equals 74 amps. Our calculated load equals 74 amps. So in this example, we can select a 100 amp main service panel. So here's the spreadsheet. Let me show you what we have here. It's called the optional service load calculation method. General lighting / receptacle loads are first in the list. And there's an input field here, a cell, where you can input the square footage of the house that you're working on. So mine's 2,100 square feet. I put that in there. Then it automatically multiplies the square feet times 3 VA, so that's 6,300. Then there's the two kitchen and dining circuits that taken at 1,500 VA each, so that's 3,000, and the one laundry circuit, that's 1,500. And this is based on, over here, you can see, 220.82 B1, 3 volt amps per square foot for general lighting and general use receptacles. Then 220.82 B2, required 20 amp circuits for kitchen, dining, and laundry. Then down here I have a number of spaces open for nameplate rating of fixed appliances. So these are the, according to 220.82 B3A, all appliances that are fastened in place, permanently connected, or located to be on a specific circuit. So I have my dishwasher, 840 VA. Everything that's highlighted in green here, you can change the value. So if it was 600 VA, you can just enter that. But it was 840, so I'll leave it at that. I happen to note in here that my dishwasher, the nameplate rating is 7 amps. But I calculate that out to VA over here. Sump pump 12 amps, and that's according to the nameplate rating. The water heater was measured at 5 amps, and I multiplied that times 1.5 and came up with 900. I didn't really see a nameplate rating for the electrical on that. The furnace, I measured 5 amps while it was running, and I doubled it to 1200 VA. Microwave. Now the nameplate rating on the microwave is 12.5 amps, but when I measured it, it was pulling 2,000 volt amps. Air fryer. I installed a new receptacle for an air fryer that we don't even own yet, but that's 18 amps according to the one that we're looking at, and that's 2160 VA. The central vac is 13.5 amps nameplate, 1620 VA. The refrigerator is 6.5 amps nameplate, 780 VA. And then further down the line here, according to 220.82 B3B, ranges, wall-mounted ovens, counter-mounted cooking units. So I provided a line for those, range, oven, cooktop. But I don't have any electric ranges, ovens, or cooktops, so that's 0. 240 volt dryer, 220.82 3BC says closed dryers not connected to the laundry branch circuit. I don't have an electric clothes dryer. Water heater, 240 volts. I don't have an electric water heater, but that's 220.82 B3D water heaters. And then down here, 220.82 B4, the nameplate rating of all permanently connected motors not included in 220.82 B3. So I gave the example of a well pump, but I don't have one. The way a spreadsheet works is that right here, it automatically takes all these numbers here that I specify and put them here. That's the total general loads, all added up. Just scroll down a little. So then 220.82B, we're going to do that demand factor calculation. So it's the total loads minus 10,000, and that's 11,740. Take that remaining times 40%, which is 4696, and then take that remaining times 40% and then add it back to 10,000, and we end up with 14,696. And that gets moved into this field over here, which has I can't show it to you here, but that has an Excel if function in it. It's an if statement. So if this value up here is 10,000 or less, then it moves that value down to here. Or it takes the value from here, it does this calculation and takes that value if it's more than 10,000 VA. Okay, and then next, I kind of listed these as 240 volt loads. You could have a heating and air conditioning load, or where you could even put a well pump down here. It could be a 240 volt load. But okay, moving down here, I listed these as 240 volt loads. So there's the heating and air conditioning load. Ours is actually 5760 volt amps. And I actually just reverse calculated that. The AC condenser is on a 30 amp circuit. So I took 80% of that, and that's 24 amps, and multiplied that times 240 and came up with the 5760. And well, the reason I did that is, as we know, those units have to be on a circuit that is rated 125% of the maximum current. So 125% is for continuous loads, and that's a load that runs more than 3 hours. Or for motor loads, you also take those at 125%. So the AC condenser is a motor load, so the 30 amp value for that is actually 125% of the actual value. So I just took 80% of it, which is the opposite of 125%, right, if you're trying to go the other way with it. So that's how I got the 5760. The air conditioner compressor is still covered up with a plastic tarp for the winter. And then a possible mini split I might put in there. But without that, my total 240 volt loads, I'm calling them, it's actually 220.82C1, which is motor loads that don't appear in the general loads list. And I should have put that right here. Okay. I should have put that description here. So the total was 5760 for the one air conditioner unit. The total volt amps for the house then, right, I add the net general loads here, 14,696 VA, and the air conditioning and heating load here, 5760, and it comes up with 2456. If you've ever used a spreadsheet, you know you set it up to do the calculations for you in the background. And that's where I came up with the 85 amps. And so certainly a 150 amp main breaker is going to be permitted here, because really a 100 amp main breaker should be permitted here too. I mentioned earlier how I'd show you how the square footage doesn't make that much difference. Once you're above 10,000 VA, everything you add is added at 40%. So it's a much smaller addition. But let's just change this 2,100 square feet. Remember, we had an 85 amp load. Let me change that. I'll double it to 4,200 square feet. And let's see what that does. It changes it to 96 amps. So my answer is still the same. A 150 amp main breaker is still permitted. What if I took that mini split at 100%? So that might be also on a 30 amp breaker, so that might also be 5760. And I'll just put that in, and look at that. It only goes up to 120 amps. So I'm still good. I have 30 amps of overhead on the 150 amp main breaker. So my conclusion is that 150 amps is fine for this, because unless I finish more living space, which is possible, or add a mini split, I'm going to be at 85 amps. So this is well under the maximum for 150 amp service. So then I went ahead down here, I created another sheet, and this is for the sub panel. And the sub panel has, I did the 2100 square feet. All the circuits in this house except the pole barn are in the sub panel. The pole barn, it stays in the main panel. It always has. It was never backed up by the Generac transfer switch. So back to 2100 square feet. This number's always going to be the same. But what I did here, now this sub panel is actually a critical loads panel for the solar inverter, the output load for the solar inverter. So the air fryer, I zeroed that out because that's going to be in the main panel. We're not going to have that backed up as a critical load. The central vac is also zeroed out. That's not a critical load. And actually today, before I made any changes down there, that was always in the main sub panel and not on the Generac panel. So that was never backed up by the generator either. So I zeroed those two out. They're not part of the critical loads. I mean, it might be a stretch to say that a dishwasher is. The sump pump certainly is. Water heater, furnace. The microwave isn't exactly critical, but there it is. We're going to have it backed up. The refrigerator's critical, and everything else is still zero. So these numbers came out a little bit lower. Let's see, over on the service panel, we had a total of 20,456 volt amps. And on the sub panel, we have 18,744 volt amps. Divide that by 240 and it's a 78 amps. So 78 amps is certainly a comfortable fit for a 100 amp main breaker protected sub panel. So that's how I did my calculations. I hope you can follow it. If you have Excel, or there might be some type of an app you can get that will open an Excel file that isn't necessarily Excel, or you can import an Excel file. Send me an email and I'll send you a copy of this. I just found a couple flaws in it that I'm going to fix. Like here, you see how I can select this and I can type things in. And here, oh, I can't do it there. I can do it on all of these. But these other lines here, that one's okay, but this one down here is locked out. Those are locked. Let's see. That one there is locked, and it shouldn't be. That's locked. All these should be unlocked so that they can be changed. So I'll do that. Other than that, and I'll add the description down here for what 220.82b says, which basically just describes this demand factor calculation of the general loads. So that's that. I hope you enjoyed that, and I hope you learned something from it, and if you want a copy, let me know. Thank you for watching. Please take a moment to like and subscribe.